class, so today I'm going to be teaching you guys about the physics behind jumping, flipping, twisting, turning, everything gymnastics related. So let's get started. The person in the air is jumping on a trampoline. The force acting on their body is gravity. When they bounce up on the trampoline, gravity pulls them back down to the trampoline so they don't get stuck floating in the air. When you jump on a trampoline, Newton's third law is being applied. When you jump up in the air, gravity pulls you back down. Newton's third law says that for every action there is an equal and opposite reaction. On a trampoline, when you jump, you are pulling the earth towards you. But you can't feel it, and no one else can feel it because one person's mass is too small to actually have an effect on the earth. Here's an example. Take a person who is 60 kilograms and one who's 20 kilograms. What will their acceleration be? Use the formula F equals ma to solve the problem. When you twist, you reach a point called the moment of inertia. The moment of inertia is when you reach a point at the axis of rotation. The formula is I equals mr squared. When a person runs at top speed and punches on the floor, she is following Newton's second law. All three of Newton's laws happen in one simple tumbling run. Newton's first law happens before the gymnast even takes one step. Until that step is taken, the gymnast is at rest, which follows Newton's first law. When she starts to tumble, the gymnast applies the force. A gymnast takes a running start when starting a pass. As she is moving across the floor, she is increasing momentum. This shows Newton's second law. The landing is also a demonstration of Newton's second law. At the end of the rotation of the flip, the gymnast above is performing. At the end of the rotation of the flip, the gymnast is performing. She opens up out of the tuck and bends her knees, which stops rotational momentum. The same way the figure skater slows down her rotation. By opening up, she slows her rotation, making the landing softer and easier. It increases the time that it takes for a gymnast to land. Because force is equal to the change of momentum divided by the time, this decreases the force the gymnast exerts on the ground and allows for an easier, safer landing. Center of gravity. To understand your center of gravity and how it affects your weight distribution is important to all aspects of flipping. Most of the time, your center of gravity is within your core, and it's very balanced. The center can change depending on the activity you're doing at the time. When you're flipping, if you are too far forward, you'll fall over onto your face. If you're too far back, you'll fall over and you won't complete the skill. You'll fall right onto your butt. Gravity is a force that attracts objects to Earth, and your center of gravity will always pull you back down. When you're doing a flip, if you over-rotate, you will fall forward. But if you're leaning too far back, then you will under-rotate and fall. Balancing your center of gravity is key to landing. The laws of physics apply to everything we do in our day. There are Newton's second and third laws of motion. The second motion is if the momentum of an object changes, there must be a resultant force acting on it. The force is equal to the change of momentum divided by the time during which the force occurs. When you land from a pass, you can decrease the force of the landing by making the landing take longer. This is why we bend our knees when we land, or use a crash mat, which is a very fluffy and firm, a very fluffy mat that helps with easier landing. Moment of inertia and the law of conventional of angular momentum are more complex to understand. The moment of inertia is the resistance of a body to being rotated and depends on body shape. The closer the body is kept into the axis of rotation, the less resistance is present. So you need less force to initiate a somersault in a tuck position than in a straight position, which is called a layout. The law of conservation of angular momentum means that once a body is rotating or spinning, then its momentum of spin must remain the same. This means that if your moment of inertia is increased, then the speed of rotation has to decrease to compensate, and vice versa. So a trampolinist or a figure skater can slow down a spin by opening their arms out. They can speed up and spin by hugging their arms closer to their body. As they bring their arms closer, they decrease the moment of inertia.